Sorry, my computer died. So I'm video got cut in half. But where we're at is we got this little equation here. Um, two equations actually. And what we were trying to do, where I left off, is we were taking this equation where so we said that since there's no b here, we're going to plug in 0, and that anything divided by 0 is so plug in a 0 there. And then find out why, and plug that 0 for the x, and 0 times squared is 0, times 3 is 0, minus 4, so we have a negative 4. Well, that is our vertex, our minimum. We have that dot, and then since there's a 3 here, I'm going to take my number times 3. So 1 times 1 is 1, but 1 times 3 is 3. So I'm going to go right 1, up 3. Same thing on the other side. 2 times 2 is 4. But then we have to take that times 3. 2 times 2 is 4. 4 times 3 is 12. So from this negative 4, I got to go up 12 spots. And that's going to leave me at the 8. So I'll do that on this side over here. And so it looks like this, but better. Not like that. It looks much better than that. And then this one says for K, so this we just did line J. For this K one, it's the same thing as J, which is 3x squared minus 4. But we're going to minus another 2. So we're just going to jump over here to 26 real quick. And it says write an equation that expresses K in terms of X. Well, it's the same thing, but we're going to minus 2. So negative 4 minus 2 is negative 6. So that's where this equation comes on. It's the same thing, but we subtract 2 from it, giving us a negative 6. And so it's going to be the same equation, but when we go to plug in our x, that's still going to be 0. But this time it's going to be a minus 6 instead of a minus 4. So our vertex, it actually shifts down 2. And then again, we're still multiplying by 3. So if I go right, 1 times 1 is 1. Well, 1 times 3 is 3, so I'd go up 3. And it's just going to be 2 lower than this one. So this dot will be 2 lower than that one. And so it's going to be, oops. It's going to, oh gosh. So it's going to be very, very similar to this last one that we did. The only difference is it's moving down 2. So that's why it says it's translated down 2 units. Because it's the same thing. It's just going down 2 units. Erase that. Again, you'll have to know me. Let me know if anyone actually watched this. Okay, good. Last page. So last page, we'll go through it. This is the vertex formula. And since we know the vertex, that's the one we want. It's y equals x minus h squared plus k. Now the h stands for horizontal. And out of your x and y, your x is the one that's horizontal. So my x is a negative 3, but if I plug in a negative 3 here, it's going to switch signs because a negative makes a positive. So that's why it says x plus 3 here for the answer. They plugged in here, but it made it positive. And then the k is how much it goes up or down, and that's just 7. So they plugged the 7 in here. And that's how they got that answer. Same thing here. No, this ain't the same thing. This is intercept form. An intercept form is y equals a and then x minus b and then parentheses x minus p. And this is for if you know the intercepts. And in this case, we know our these two numbers here, b and or two letters here, b and p represent our intercepts. And so our numbers are -3 and 5. And since these are both minuses, the signs are going to change. So if I plugged in a negative here, that's where they got a +3 here. and then we just plug our positive 5 in, and it becomes a negative 5. And that's it for our answer. This one, same thing. There's 3 numbers, though. And so you're just going to do one more extra, you're just going to multiply by one more extra number. So we got our -2, which is going to turn into a +2 because, again, the negative. Our 5, which will be a x minus 5, and our 6, which is x minus 6. So that's all you do for this one. This one's a little bit different, and the best way I can explain it is, and this won't be on the test, this one, but we know our -3, that's where they got the +3 here, and then the 4, that's where the -4 came from. Well, this 0, we've seen problems like this before, like when we have to factor out a number. So if we had to factor something out like a 2, and then we get, I don't know, just an example, x plus 3 and x minus 4. So sometimes we have to factor out numbers, and then we get left with this little 2. And before we'd set them all to 0, and we'd say something like 2 equals 0. And then x plus 3 equals 0, and x minus 4 equals 0, and we'd solve it. Well, this little x just means that there's another number out front here, like this 2. And so you just put an x up front when you're writing the equation. But like I said, it won't be on the test. All right, so now the last bit, erase this, and click the little arrow here. This one we just have to tell what's going on. With this here, what it most looks like when we graph those points. So 0, -4, I'll plot that. 1, 2, I'll plot that. 2, 4, 3, 2, and 4, -4. And you can see that it makes like the U shape that we've done all chapter. And this is quadratic when it makes this U shape. And then it says write the equation in any form. In the form that you could do it any way, but the easiest form, since we got our vertex, is and our vertex right here is 2, 4. So that's our vertex. So since we know that, we're just going to plug that in to figure out our vertex. And we got to use our vertex formula, which is y equals a parentheses x minus h squared plus k. And so we're just going to plug in those numbers that we know for the vertex. And our vertex is our x is 2, so we're going to plug a 2 in here and a 4 for k. So I'm left with a x minus 2 squared plus 4 for k. Now, the problem is we don't know what a is. So to figure out what a is, we can pick any point we want. And so I'm just to plug in to find an x and a y. So we're going to find something to plug in for y and x, and then we can get a alone. So I'm just going to do this one because it's nice and easy, this 1, 2, 1. But if I wanted, I could do 4, 2, or this 0, -4, whichever one I want. But I'm going to plug in 1, 2 for x and y. So we'll use this point 1, 2, and we'll plug in our x and y to figure out what a is. So y is 2, so I'm going to replace this y with a 2. A is still a, that's what we're trying to figure out. I want to point out that this is wrong too. I didn't make this, but this answer is wrong. It's not supposed to be a -1/2. It's supposed to be a -2. Then our x, we said we're going to use this one. So it's 1 minus 2 squared plus 4. So 1 minus 2 is a -1. But a -1 squared is a +1. -1 times -1 is +1. And then I multiply this a into it, and it becomes 1a plus 4. Next, we want to get our a alone. And all we have to do for that is -4. So if I -4 on both sides, I'm left with a -2 equals A. So now that we know that A is a -2, I can go back and write my equation. And it's -2 x minus 2 squared plus 4. And then that's what you want for that one. I doubt this will be on the test either. So, oh, erase this one. And these are the last two. So do the points appear to represent a linear, quadratic, or exponential? So if these were linear, I would be adding the same numbers every time. So I would add 2, add 2, add 2, add 2, and that would be a linear one. Quadratic, quadratic's a little more complicated. I would find what they're changing up by every time, and then I'd look at the next set to see if that is the same pattern. Exponential is the one we're looking at for this time, though, because if I look at my y's, if I take 2/3 times 3, well, 3 times 2 is 6, and 6 divided by 3 is 2. So this one went up by times 3. And then 2 to 6 again times 3. And 6 to 18 times 3. And 18 times 3 again to get 54. So it's going up by times 3. And that brings us to this equation. And this equation is y equals, and this is for exponential. And it's supposed to be, we're going to use this 2 here. And that's because 2 is our y-intercept. This is 0, 2. So it crosses our origin at 0, 2. And then since it's being multiplied by 3 every time, that's where this 3 comes in. So it's 2 times 3, and then we just put the x here. That's the test. I hope some of you get to watch this before tomorrow. Good luck. I'll see you Monday. Have a good weekend. Goodbye.